Hey guys, for whatever reason that last video that I put under the advanced category, people said I guess it wasn't enough, you need more. So I guess I'll do one more. Hopefully this will, it's a little more difficult probably than the last advanced one, but I think this should be enough for you. So we've got two equations to deal with this time. We've got r equals 3 sine theta, and we've got r equals 1 plus sine theta. And the question is, find the area of the region that's inside this one, but outside this one. Okay, there's really no way to do this without a good picture, so let's at least graph it and kind of go from there. Okay, so let's get this going. Alright, so y1, I'm going to do 3 sine theta. R1, R2, I'm going to do 1 plus sine theta. And we'll do a normal, we'll just go 0 to 2 pi. 0 to pi. And I'm not sure how big this one gets, although the one of them is 3 sine theta, so I'm guessing it'll at least be 3's. So let's go -3 to 3, -3 to 3, and see what happens. Alright, there's my circle. I knew that was coming. Okay, so that's not bad. I can kind of see that. I could probably zoom, I could probably make the y's maybe go -2 to 2 and then -1 to 3. So let's just to zoom in. -2 to 2, -1 to 3. Get a better picture here. There's my 3 sine theta. And there is my 1 plus sine theta. So let me draw that here so I can kind of look at it. There's, let's call that R1. Excuse me, and R2. It's sort of like, I don't know, something like this maybe. I think they call that like a cardioid or something. It almost looks like a heart, upside down heart. Okay, so inside the circle, but outside the cardioid. So that's basically this. Right, that's the region we're looking for. Right? Okay, so if I could figure out, well, first of all, we know the formula, right? We're going to do the area under the outside curve and then subtract the area under the inside curve, and what's left over will be my area. So if my radius would, here's a sample radius, a sample sector, right? That's the sector of the whole circle, right? I'm going to do the whole circle, but then I'm going to subtract out this part. So subtract out, here's a sample sector for that one. Okay, it's hard to see, but it's basically area between curves. Area under this minus area under that. Okay, except it's not technically under. It's sort of, it accumulates as the radius sweeps through. So let's figure that out. So this is going to be from, I have no idea actually. I don't know what this is. I got to figure that out. And I guess I can go all the way around, or I can just go here and double it. So I think that's what I'm going to do. I'm going to double from this value, whatever that is, I don't know yet, to, this has got to be what, pi over 2, of the bigger one, which is 3 sine theta, squared, minus the smaller one, the inner one, 1 plus sine theta, squared, d theta. So where do these two things meet? Well, they meet whenever 3 sine theta equals 1 plus sine theta. So let's solve for theta. Subtract sine theta from both sides, so that's 2 sine theta equals 1. Sine theta equals 1/2. When is sine theta equal to 1/2? Hopefully you know this without having to look up the unit circle. But half is the smaller one, so the y value is smaller when theta equals pi over 6. So that's where they would meet, pi over 6. Okay, we can actually confirm that. Go right to the calculator, second calculate, pi over 6, and you can see it right there. Okay, so, or maybe you can't see it. Let me zoom in a little bit. Can you see that? You see the tracer there? See it? See it? How about now? Can you see it now? How about there? Extreme close-up. Whoa! See it? 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 Okay. So theta is going to be pi over 6. So we're basically just going from pi over 6 to pi over 2, and we could double it. I mean, you could figure out where it would hit again. Sine half would be what? That'd have to be 5 pi over 6. So I could have just gone from pi over 6 to 5 pi over 6. It really doesn't matter. But at this point, I think we're going to just use our calculator. Let's see, 9 sine squared. Yeah, it's going to get messy. I don't think I'm going to be able to simplify that easily by hand. So I will use the calculator. So let's see. Math 9. And my, not there. Because then I don't think it'll let me. Actually, it might have worked. I don't know if it would draw it right. But Math 9, let's see, the outside one is, the bigger one, I should say, is 3 sine theta. So 3 sine theta squared minus 1 plus sine theta squared. And let's see, I got the 3 sine theta squared, I got the 1 plus sine theta squared, and then comma theta, comma pi over 6, comma pi over 2. And I don't think I doubled it yet. So this looks like it would be 2 times, that looks like pi, so 2 pi. And there you go. Okay, so the let's see, the area underneath, or the area in between those two curves, looks like it is 2 pi. And something doesn't feel right there. Oh, I wonder how many of you, again, I don't know why this only happens when I do the videos. And if I knew how to edit these things, I'd fix it. But I forgot my 1/2, right? Isn't area 1/2 r squared d theta? I think in the back of my head I knew I was doubling it, and I think I'm like, okay, I know I'm going to end up canceling out the 1/2, and I just forgot. So technically there'd be a 1/2 here also, which would cancel out, and then in actuality this 2 wouldn't even be here, and in actuality that 2 wouldn't be here. So it actually is pi. So this equation is sort of taking into account that I doubled and took a half. Okay, so sorry about that. As soon as I was writing it, I just felt like I was missing something. So the correct answer should just be pi. Okay, let's just double check. Let's be sure, because I don't know. I'm sure you're feeling a little strange about that shenanigan. So let's just do it as if I was going all the way around. Let's go to 5 pi over 6. So let's do it the right way. So pi over 6 to 5 pi over 6. 1/2 of this thing. It's the same equation at least, right? It's still big radius squared minus little radius squared. So it's still this. Okay, and now let's figure that out. Alright, let's try again. So I'm going to actually copy this, but this time I am going to put in the 1/2. And instead of going from pi over 6 to pi over 2, I'm going to go from pi over 6 to 5 pi over 6. And if I get pi as my answer, then I must have done it right. Oh boy. What did I do wrong this time? Let's see. I got my sine squared. I got my 0.5. Let's see. I feel like I missed a parenthesis in here. I think by adding in the 0.5, I should have put, because I have a bracket, I think I'm missing a parenthesis there. So hang on 1 second. So 0.5 times the whole thing. Oops. Times the whole thing. And that means I would need another closed parenthesis, let's see, after the squared. There it is. Okay, sorry about that. Adding in the 0.5 wasn't as simple. I basically just put the 0.5 right here, and it only applied to this part. So I had to recreate the bracket. Alright? So we must have done this right, and which makes sense since obviously I had forgotten the 1/2 originally. Okay? So good news, bad news. Good news is it's still same formula. Bad news is we should be able to get in between also, using the same strategies we've used in, ABC. Alright, hopefully that helps. Let me know if you have any questions, and good luck with whatever problems you're able to try tonight. Okay? See ya.